Hello, Vicky. Hello, Future Hope. Hello, Hunter. I'm so sorry to be late. My internet connection today is letting me down. Can you all hear me okay? Okay. I know it's Monday morning in India. Welcome back from the weekend for the Future Hope students. I'm sorry I didn't see you over the weekend. I know you were at home catching up with, thank you. Hello. I know you were at home and not at school on the weekend, so hope you had a good weekend. And Vicky, how was your weekend? Or it's still going on?
Is winding down. Actually, I had a whole day off today. It was wonderful.
That reminds me of the day you spent with Evan and me a weekend ago, which is good.
I know, that was wonderful. The dogs got a bath today, though, and the gardens got a lot of love, so I'm feeling very relaxed. One more week of school, and then we have a 2 weeks break.
I see. Will the dogs be able to make an appearance on Zoom today for the benefit of the others on Zoom? But if it's going to be logistically complicated, please don't.
Probably not little boy, but Angel can make an appearance. Angel can, and we have school pictures tomorrow. So she got a nice bath so she can be beautiful for school pictures. So,
and that's wonderful. So for the Future Hope students, Angel is the name of a dog who adopted the Akaula school that Hunter studies at, that Vicky runs on the island of Molokai in Hawaii. And I mean it when I say the dog adopted the school, probably more than the school adopted the dog, although it's a mutual adoption. But the dog used to belong to a couple who lived close to the school. And one day the students brought the dog to school saying this dog is lost, even though the dog had a collar and a tag and phone numbers of owners, etc. So anyway, the dog started, if I understand correctly, the dog started spending the daytime at the school, getting a lot of attention from all the students, and then in the evening would go home to be with her biological, no, not adoptive humans, and to spend the evening and night with them. And then after a while, the humans who adopted her originally gave her to the school. So now she's at the school and she goes surfing. She has her own life vest. In fact, when we went snorkeling, she went out on a little board into the water also. So hopefully she makes an appearance for all of you.
I think she will.
Okay, so I'm going to share my screen so you can see what is going on in the astronomy side of this, of where I'm sitting. So please bear with me a few minutes while I set that up. In the meantime, if there are any questions for anyone at all, please feel free to ask.
Good morning, sir.
Say that again. Your audio cut out. Please say that again.
Hello, sir.
Hello.
I have a question.
Please ask your question.
My question is that which type of material or alloy you use to build a satellite?
So that's a very good question. I would be guessing at the answer because I'm not in the business of building or designing satellites, but I can ask my wife. I know the metal has to be strong. There's Angel. The metal has to be strong. It has to be light because the heavier your spacecraft is, the more fuel you need to boost it into space. So I think there's I don't know the answer, so I'll be guessing. But let's Angel is here, so we should give Angel. Angel is not looking at me. Hello. She's so cute. She does look all bathed and clean. Wow.
She's trying to find where the voice is coming from.
Angel, I'm right here. Hello. Woof.
Oh, right there, right there. There's Uncle, right there. Ah, yeah.
She probably sees me in 2 dimensions. Oh, look at her. She's so sweet. Thank you, Vicky. Oh. So yeah, I don't know the answer to exactly what metal or metal combinations are used. I'm sure you can find out about this by Google searching, Googling this question. If I find out more, I'll pass the information along to you. But you know, I really have never been in the business of designing or building satellites for space. So you asked a good question. My family continues to get excited about the Molokai visit in December, Vicky. Super excited.
Thank
Go
you.
ahead. Yeah, go ahead, please.
We'll be here. Looking forward to meeting them, really.
Thank you. Thank you. All right, so I'm still getting ready to share my screen, so please give me another few minutes. All right, so DEIMOS 5 tonight. I'm running some Python software on my computer to process the data that we've been collecting with the telescope. That's something that I'm actively in the middle of doing. But that is slowing down my computer a little bit, and that could be why it was having difficulty reconnecting to the internet. You all remember Antara from a few nights ago and yesterday. So today she went back from Hawaii. She's actually flying back right now, back to the east coast of the US. Ah, there's Alessandro. Hey, Alessandro. I'm going to share my screen and see what you can. This must look familiar to you now because we've been using the same instrument all 10 nights, you know, the DEIMOS spectrograph. Hi, Alessandro.
Hello.
Hi there. I'm sharing my screen, but my computer's being very slow because it's running Pipet in the background. Maybe that's why. I don't know why, but it's being rather slow with the updates.
Right. We'll be staying on source for 20 more minutes. So
Okay.
you have plenty of time to update your screen.
If it takes 20 minutes to update, I'm in real trouble. But I'm going to get our star list ready for Monday and Tuesday nights. Hey, Ivana. Ivana, feel free to introduce yourself, or I can introduce the group, and then Alessandro and Ivana, I'll let you introduce yourselves. Should I? And if Michael and Rita want to say hello, they're welcome to, of course.
I believe Michael just went standby.
Got you. So yeah, it's showing my screen very slowly, but Vicky runs this amazing school called the Akaula School on Molokai that Evan and I visited. Vicky, Ivana who is sharing the same Zoom connection with Alessandro, is a former PhD student of Evan's. So Ivana is my PhD grant student, and Alessandro has been working closely with Evan and all of us on this more than one project really, but a project to understand some of the small galaxies around Andromeda.
Aloha.
Hello.
Aloha.
And Future Hope is the school in Kolkata that is, how many students are in the Future Hope room today? Is it the usual 25 students? How many students are there?
Yes, sir.
25, okay. And it's the same range of grades, class 6, 7, 8, 9, and 11?
Yes.
Okay. Okay. And then Hunter is a student at the Akaula School in Molokai. And Hunter and Walker have been on the Zoom call from time to time. Hunter is very interested in astronomy.
Good. Happy to have you on board.
If you, Ivana and Alessandro, if you want to say anything at all about your path to becoming an astronomer, please feel free to do so. And then I will later go over what we're seeing on these screens.
Go first.
Yeah, sure. So, hello, I'm Ivana. I'm a postdoc at Princeton University. So I work as an independent researcher, but I'm not a professor, is basically what that means. So yeah, I've just been interested in astronomy since I was a young kid, and I went to the University of California, San Diego, and got a degree in physics, and then went to the California Institute of Technology for my PhD. I guess that makes it sound a little bit easier and more linear than it was, but yeah, I can talk more about problems I encountered later.
And Ivana, the Future Hope students, and of course, Vicky and Hunter and Walker all met Evan. And Future Hope students met Evan on Zoom during Shadow the Scientist. So thank you for that. Thank you for the introduction. Oh, that's great. Alessandro?
Yeah, I'm Alessandro. I am the one which is mostly behind the wheel tonight. So be observing a bunch of very interesting stuff, stars and galaxies and stars in galaxies. And so, yeah, I mean, I am basically in the same type of position that Ivana is. So I am a researcher, but I am collaborating, of course, with professors and with other students in like a number of research programs. And again, as for me as well, I think I was always interested in astronomy, and I was talking with Raj about this. I think people, they get a liking in astronomy either just looking at the sky and like just fascinated about like the visual experience of astronomy. And some people, they get fascinated by the ideas of the universe, and I was one of them actually. So I was really fascinated about this idea that there is this immense space, above Earth, and there is so many things, and a lot of people that really, they think a lot about Earth, but not a lot of people that think a lot about what's up there. And so that's where I started, and I started. I did my studies in Europe. First in Italy, then I moved to England, and then the Netherlands. And I started with a very deep passion about stars. So that's what I started working with. And then along the way, I found out that stars are really nice. And you can also use stars to learn more about galaxies, because of course, stars are made of galaxies. Galaxies are made of stars. And so that's sort of where like I landed scientifically. I'm a little bit in the middle. I do some research just on what stars do and how they evolve. but also on what can we learn on galaxies using the stars they're made of. So, and this is exactly what we're doing tonight. We're doing a bit of both, thanks to the various observations we're taking, but mostly we are looking at these tiny galaxies which are around the large galaxy of Andromeda. And so we're looking at actually individual stars inside of these galaxies, and we're trying to understand exactly how fast these stars are moving and what are they made of, so that we can learn a little bit better how this tiny galaxy actually was formed and how did it get to where it is today.
Thanks, Alessandro. I've stopped sharing my screen so people can see people more easily, and then I'll go back to screen sharing.
Yeah, and I can always move this a little bit more towards the.
And I know that a few days ago, we went around Future School and all the students talked about their favorite subjects. And one thing we heard very frequently was mathematics was a subject that a lot of people are fond of. Science is another subject. We also heard language like English, Bengali, and as scientists, we have to communicate a lot. So use of language is very common in science. Otherwise, the research we do doesn't easily get communicated to others unless we can write and speak about the research. So that's an important part of what scientists do. Did Walker and Hunter, did you want to introduce yourself? And Vicky, I would love for you to say a few words about your school as well, in whatever order you would want to go. Hunter, go to you first, Vicky.
Hunter, if you're there, speak up.
Oh, sorry. Hello. My name's Hunter. I go to Akula School. Miss Newberry is my teacher. And yeah, my brother's here on Zoom, Walker.
Yeah, you see him?
Yep. And yeah, learning about space.
You both are
been-
very fond of space, right?
Yeah.
Sorry, Vicky, go ahead.
Yeah.
Hunter, and Walker, you both been logging in pretty regularly, yeah?
Yeah.
Excellent. You'll have to fill me in tomorrow because I was truant for a couple of days. As Hunter said, I'm a co-founder of a small private school. We have about 40 students, grades 5 through 12, on an island that only has 6,000 people. So small population, but small population on the island. And our classes are in English, although we have a lot of students who've come up through the Hawaiian immersion program. That's a question I'd like to ask. So when you talk about the need to communicate, Raja, in science, what is the language most frequently used when you're communicating internationally?
I would say English now, but I don't think that's always been the case. I think there was a time when it was really important to speak German. I think it is also the case that communicating in Mandarin, communicating in Spanish, these are, I think as science becomes more universal, universal access, ideally, science communication should mirror the language of other communication. Right now, I think English is I may be wrong about this, but I think it's the dominant language of communication among scientists. I'm not saying it should be that way, but I think that's how it is.
I was just thinking as a way for young people too, who want to prepare for a career in science, to look at a language for us outside of English that would be most helpful in international communications.
One of the things we've been thinking about for Shadow the Scientist is, and we've done a few like this, sort of bilingual communication for some sessions that are tailored to, for example, we were working with a group of students in Monterrey, Mexico, and we had a bilingual astronomer who was fluent in Spanish and English. She was helping to moderate that session. We've had a session in Bengali and English as well for a small group of students. And again, because the students who were taking part in that particular session, Bengali was their first language by a very far margin. Now, the Future Hope schools, just from your questions, it's very clear that all of you are extremely fluent in English, and whether it's your first language or a second language, it's a very close second language, even in cases where it's a second language. In fact, we spoke with a group of people, adults, mostly adults, not children. This would have been about a year and a half ago, where Spanish was their second language. And their first language was, they were a group from the Comcac tribe in northern Mexico in the Sonoran Desert. So that was also bilingual in Spanish and English for my benefit. And so I could speak in English and with a smattering of Spanish. And then the person who was doing the translation was completely fluent in Spanish. Yeah, this is something we're starting to think about, is at least bilingual moderation of these sessions. Often what happens is many of the technical words, like charge coupled device, you don't bother to translate that. You use the English words, but you explain its functionality, perhaps in a different language. There are words like light, perhaps even waves, certainly waves, it's a common enough word. Rainbow, those are words that, so I think ideally, as I'm thinking about it, where the second language or third language might be helpful is connecting something as abstract and technical as the universe and our observation of it to everyday experience. So for example, when we see a spectrum of a star, connecting it to a rainbow, for which we're using words in other languages to describe a rainbow, might be a good way to make a connection. I'm thinking about this as we're discussing it. I haven't really sorted out how language will play into this, into these sorts of sessions.
I think one of the things you do really well is find metaphors and examples, and that probably comes out of that need to communicate difficult concepts. So that kind of starts to make sense to me.
Any thoughts from anyone on the call? I mean, I'm particularly looking at Future Hope. What are your thoughts about language of communication? Does anyone want to offer a comment from the school? Please feel free to speak up. Yeah, go ahead. This is not a question. It's more, what are your thoughts about language? If maybe we could have a show of hands if you feel English is your first language versus second language. If you put up your hand, if English is your first language. I'll put up my hand. Even though I grew up in Kolkata, I find when I'm speaking in Bengali, I have to first compose the sentence in English and then translate. So we have a few hands. Yeah. Sorry, go ahead, Prem.
Actually, we'll speaking in different languages where it depends on the situation.
Yes.
If we have to, if the situation want us to speak in English, we speak in English. If want Hindi, we speak in Hindi, Bengali.
I see.
We are fluent in all three languages.
So Hindi, Bengali, and English are the three languages that the students of the school are. If you had to, so I know when I compose a sentence in Bengali, I find myself first in my head composing the sentence in English and then translating. Does that process feel familiar to you? Or...
In English, I prepare in my mind and then see.
In what language do you prepare the thought in your mind?
English.
In English, I see. Then I would say English is your first language. And then when you want to say a sentence in Bangla, do you first compose it in English and then say it in Bangla, or does it come naturally to you in Bangla?
Naturally come.
Oh, okay. So for me, I find that very often I have to first compose the thought in English and then translate it to Bangla or Hindi or Spanish. And because of that, I feel English is my first language. Which language? They say the test of what's your first language is what is the first words that come out of your mouth if you're in a panic situation or you're surprised. That is the test of what your first language is, because then it's instinct. It's not, you're not thinking. It's just instinctively what language comes out of your mouth if someone were to suddenly scare you, or you were to suddenly slip and fall, or something sudden. What language comes out of your mouth when that happens? Yeah. Go ahead.
Our mother tongue.
Mother tongue. What is that for you?
Mine is Hindi.
Hindi. I see. I see. How many people would say their mother tongue is Hindi in the room? Put up your hand, please. I'm not going to put up my hand for this one. How about Bengali? How about Bengali?
Hindi.
So Hindi is more common, I see, than Bengali. No?
Yes, sir.
You think Hindi is more common? Okay. Okay. Any other languages like Urdu? No? All right. Now, what else was I going to say? Today is today Rosh Hashanah, or it was? I think it is. It's today's the Jewish New Year today. When do you celebrate the Bengali New Year? Is that in the middle of April?
April, 15 April.
15th April, yeah. So today is an important day in India too. It's the second day of the big festival in Kolkata called Durga Puja. Right? Isn't today the second day?
Second day.
Today's the second day. Second day.
Yes,
Yesterday was the first day. It's a 10-day.
First day.
Today's the first day. Is today the first day or the second?
First, yes, sir, first.
Was Mohaloy on today, or was it on Sunday?
Yesterday.
Yesterday. Okay, yeah, that's what I thought. Okay.
Maunakea was yesterday and today is the first day.
Oh, today is the first day. I see. I see. And then when is Bijaya Dashami? What date?
5th.
Sorry?
5th October.
5th October. I see. I see. So there's a 10-day festival that's going on in the part of India that Future Hope is located in Bengal. It's the biggest festival of that part of India. And the goddess Durga is supposed to come from her husband's home, from her in-laws' home, to her own parents' home. And it's a symbolic transition from heaven, where her husband lives, to earth, which is her birthplace, where her parents live. So she comes to her family on earth for 10 days, and it's a 10 days of celebration. It's the biggest festival in that part of India. And it's become, I would say, more than a religious festival. It's become a cultural and art festival. My sister, who's an art historian, recently wrote a proposal to UNESCO asking that this festival be made a heritage festival. You know, UNESCO has heritage buildings and permanent structures, but they also have heritage events. And thanks to her efforts and the efforts of her team, UNESCO declared Durga Puja of Kolkata. Durga Puja is the name of I'm going to put this in the chat. Durga is the name of the goddess. Puja is, worship of Kolkata. has become a UNESCO heritage event. So my sister was in the news a lot with the Chief Minister of Bengal, Mamata Ganguly, and with a very famous Bengali named Saurabh Ganguly. They were all on stage together just before, while I was in India. So all this was going on. So my sister suddenly became an overnight celebrity because of her work in making this festival a UNESCO Heritage Festival. Okay, I'm going to share my screen. Go ahead. Someone was going to say something. Had you heard that Durga Puja of Kolkata has become a UNESCO Heritage Festival? Had you heard that at Future Hope?
Yes, sir.
You had heard that. Okay. Yeah. I'll put my sister's name in the chat because she's an art historian who spent 10 years. I mean, she does research in other topics too, but she spent 10 years of her life researching this puja in Kolkata and looking at how it's used as a vehicle for artistic expression. So that's her name. She has the same last name as me. And the book she wrote is called In the Name of the Goddess. It's how art is done in the name of the goddess. And it's a book that, it's a wonderful book. It's this big, thick book. It's 10 years of her work based on on how this festival has become a vehicle or a conduit for art. Beautiful art, really. Alessandro and Ivana, you guys sound like you're in the middle of a mask change. I don't know if they can hear me, but I'll share my screen.
Hello, sir.
You are?
Hello, sir. Have you drawn something on the theme of Durga Puja?
Have I drawn anything on the theme of Durga Puja? Yes, I have
Sir.
two. I have two pieces of art that have some connection to Durga Puja. Would you like to
Can
see
you
that?
please?
Yeah, sure.
Yes, sir. Yes. We'll love to.
Thank you. Thank you. All right, let me see. Let me show you. I think one of those I showed you already, but let me show it again. Give me a moment. Sorry. I have to just find it on my screen. Okay, so I'm bringing up the first piece, and then I'll bring up the second. I think I showed this. I know I showed this before. In my portrait of my mother, there is, of course, a portrait of Durga in there. You remember this one? There's Durga. This is the goddess we're talking about. I'll zoom in. This image of the goddess is very common at this time of year in Kolkata. So this is one of my drawings, Durga. And then, of course, you saw this before, right? And then next to her, typically there's not paintings, but sculpture of this goddess. And she's flanked by her 4 children. And one of her children is Ganesha, who's up here. Let me show you another one. And this one I did while my mother was alive, while using a technique that she was exploring. And this is an oil paint. Sorry, this is a it's a watercolor. No, yeah, it's a watercolor, but on glass. It's an unusual kind of medium, watercolor on glass. There you go. It's a stylized goddess. She's got these are meant to be her 10 arms. Each of her hands is holding a different weapon. She's meant to be the protector. Her spirit animal, if you like, is a lion. That's what's represented at the lower right. She is slaying a demon whose spirit animal is a buffalo. And she has a third eye. She doesn't just have 2 eyes. She has a third eye in the middle of her head. But it's stylized. I haven't drawn the eyes realistically or anything like that. But so if you see, yeah, sorry, go ahead. Thank you very much. So this is a technique called glass painting, where you it's a particular the finished product looks a lot like a stained glass that you might see inside a church window. But you first paint the black, and those lines form a little bead. They're slightly raised, and they form islands on the glass. And then when you put any other color, like the color red or yellow, it fills that island completely. It just flows throughout that. So you don't have to paint really. You paint the black, and then the other colors you just fill in by putting drops.
We have done this.
You've done this. Okay. Excellent.
If you come to picture of, if you visit, go in art room, we have the glasses paint like this.
Oh, fantastic. Yeah. It's not if, it's when. When I visit, I will come and definitely come and visit.
Yes,
so
sorry.
I'll definitely come. Like I promised Vicky, I would come to Akaula School, and that has already happened. In fact, I'm going to visit a second time. So in case I happen to come to Kolkata in the, I know I'm supposed to go in August next year, but in case I go before that, I'll certainly come to visit you all. Let me think about what else. These are the only two Durga paintings I have. I don't have any others, but let's see.
When was the last time you visited Kolkata during Durga Puja?
Oh, it's been a very long time since I visited during Durga Puja, because it usually takes place around late September or sometimes as late as mid or late October. And usually that time our term has started and I'm teaching. So it's been a long time since I last visited during Durga Puja, maybe even 15 years or more. So I usually visit in August or December. And so, neither of those coincide with Durga Puja. So my last 3 visits to Kolkata were in the months of August, February, and and January, actually. So I tend to go over the winter months or summer months, but not in the fall. And one of the names for Durga Puja is Sharadiyo Chab, so that which literally means fall festival. So it's held in the fall. Right, Sharad, am I saying it correctly? For Future Hope, you've heard the term Sharadiyo Puja, which means fall worship.
Yes, sir, you are correct.
Okay. All right. Oh, Rita's connecting. Oh, wonderful. Rita. Hey, Rita. Hi, Rita. How are you? So
hey
we
guys,
have.
thought I'd just pop on and say hi.
Thank you. What's going on the summit right now? Summit of Maunakea.
Yeah, so the summit looks pretty good. It's very clear. The seeing is excellent tonight, so that's always good.
Is it still holding at 0.5 or thereabouts?
0.5, 0.6, which is pretty good. I think
Very
everybody here
good.
is happy, so.
I
Nice.
hope the conditions are that good tomorrow and Tuesday night. I really need the good seeing. We're working in very crowded fields in Andromeda's disk, and the better the seeing, the more isolated our target stars are from the light of their neighbors.
Yeah, well, we'll see. I've got my fingers crossed for you. So tonight is actually my last night of this shift, so I
Okay.
think you'll have Arena working.
Arena tomorrow. Okay. Tomorrow and Tuesday. All right.
Mhm.
And who's our SA tomorrow? Support astronomer tomorrow. Is that Michael?
That's a good question. I can look it up. I don't think it's Michael.
I don't think it's Michael either. I think it's Jim.
Yeah, it's Jim.
Jim is on tomorrow and Tuesday.
Yeah.
So Rita, a group of us tried to go up to Maunakea on Saturday, and we went up to the mid-base level, went to the visitor center there, but we had an all-wheel drive rather than a four-wheel drive that had low gear, not first gear. So the rangers didn't let us up to the summit of Maunakea.
Really?
Really? Yes.
Oh
yes.
no.
They become very strict. Yeah.
Yeah,
Alessandro was
wow,
there.
that's
He can vouch
surprising.
for me. Yeah. And Ivana was there. Yeah, they wouldn't let us go up beyond.
Oh
They
wow,
just would not
that's
let us.
super sad.
It
I'm
was
sorry.
a hard no. It wasn't like this is an option. It was a hard no.
I
They said,
am sorry about that. I feel
That's
like
okay.
all-wheel drive probably would have been okay, but
Yeah. They literally said it's because it didn't have first gear. and it had L, but low gear, but not first gear.
I wonder if L is actually first gear.
I don't know. My car, so I drove a rental car up to HP, and Stefan Kimura, who's one of our students who lives in Kona, he kindly drove his mother's all-wheel drive truck up to HP to meet us with the idea that he was going to take us up the rest of the way. But no, none of us could go beyond HP.
Oh,
HP is
I'm
a place
sorry.
called Halepohaku at 9,000 feet. So that was I mean, it was fun driving up there. It was still beautiful. The visitor center
Yeah.
is so lovely, but we
I
couldn't
mean,
get to the summit.
Halepohaku is nice, and you can like walk up that little hill right next to it and see, sunset there, which is, it's pretty, but it's definitely not the summit.
Yeah, we were there just in the middle of the day, so we came back after hanging out there for a little while. We got used to the altitude there, but then came down. We didn't go further up.
Yeah. Well, I don't know. Try again with real four-wheel drive. I don't know what to tell
Yes,
you.
exactly.
But at least you didn't have to deal with the 14,000 feet elevation stuff, because that's not always fun.
No, we didn't have to deal with that at all.
Very cool.
Sir, I have a question.
Yes, please go ahead. Go ahead. What is your question?
Sir, is the Earth always same distance from the sun?
Not always exactly the same distance from the sun, because the Earth is in a very slightly oval shaped or elliptical shaped orbit. It's not a perfect circle, but so the distance of the Earth from the sun changes very slightly in the course of the year. I have to look up the exact ellipticity of the Earth. Then I could tell you what percentage of how much the distance changes as a percentage. It's not like sometimes it's twice as close as at other times. It's not that extreme. It's less than 10% the variation. But the average distance is 150 million kilometers. 150 million kilometers, and in light travel time, it's about 500 seconds or 8 minutes of light travel time. If you want to measure the distance in terms of light travel time, then it would be about 8 minutes or 500 seconds. But in kilometers, it's 150 followed by 6 zeros. So if you remember your scientific notation, it's 1.5 multiplied by 10 to the power 8 kilometers. Hey, Walker, welcome back. And Rita there, Walker and Vicky have connected from Molokai, and Future Hope is connected from Kolkata in India. And all of them have been part of Shadow the Scientists multiple times, in fact, in the last few days. So
Super cool. Yeah, so I'm just going to be up here operating the telescope, but if you guys have questions or anything, just, feel free to shout and I'll be here.
Rita, did you, before you took on this job at Keck, what was your career path? What led you to Keck, if you have a moment?
Yeah, sure. Yeah, so my background is actually, I did undergrad as an astronomy and physics person.
Okay.
And then I actually did a master's degree in optical engineering. And before I was at Keck, I was actually operating for Subaru telescope, which is right next door to us. And I spent about 9 years there operating telescopes, and then switched over to Keck maybe a year and change ago. So I've been here for a little over a year.
I see. Where was your master's in optical engineering from? Which institution?
University of Arizona.
Oh, this is very well known for its optical engineering, of course. Yeah.
Yes, it is.
Wonderful school.
Yeah, it was a really good program. And if anybody is interested in optics, that's kind of the place to be.
Fantastic. Walker, you have your hand up. Go ahead, please.
I have a question for Rita. What's your favorite thing about physics?
My favorite thing about, I'm sorry, I missed the last bit.
Physics.
Oh, physics.
Favorite thing about physics, oh man. I gotta think about that one because honestly, physics isn't my favorite. I like astronomy much, much better. And I really like the planetary aspect of astronomy. So, you know, studying planets and extrasolar planets and stuff along those lines. It's very cool stuff. But I guess that's not super physicsy, although all of that does involve physics.
Mhm. Yeah, I mean, you're right. It does all involve physics. That's why, you know, it's called astrophysics. It's the physics of how things in space work, you know, gravity, light. This is one of the cool things, of course. The same physics that operates in our laboratories on Earth also operates in distant systems like stars and planets. And that helps us make sense of them.
Yeah, so the cool thing about physics is that it's everywhere and it describes everything. So it tells you how everything works, which is pretty cool.
Wonderful, wonderful. Thank you. Thank you so much, Rita. So we're taking spectra tonight. This thing that says, if you can see my cursor, says Kim1R1. This is a population of stars in the sky, a set of stars in the sky. And we're trying to figure out what they are, whether they're a cluster of stars, do they have dark matter associated with them? Are they the same age? Are they just a chance superposition? Some in front, some at the back. We're trying to figure that out. And when I say we, this is being led by an astronomer named Marla Geha, who is a professor at Yale. She and I go a long way back. She was my PhD student many years ago, from 1999 to 2003. And we've continued to work together. Marla is working with Alessandro, Ivana, Evan, who all of you have met, others as well. And so Marla is trying to figure out what this group of stars is. And there's 3 such groups that Alessandro and Ivana and I are observing tonight. And I'll probably also get more spectra of them just to improve the quality of the data tomorrow night and Tuesday night. So these are some of the smallest galaxy fragments or galaxies that we know about in the universe, and trying to understand them can be important for understanding the building blocks of the universe. You know, we know that galaxies can collide and get bigger by cannibalism. I talked about that at the Akaula school last weekend. So understanding the smallest systems that are the victims of cannibalism, if you like, is important. Trying to understand what sort of chemical processing has gone on in them, how and to what extent they're bound by dark matter, how much dark matter they contain. Dark matter is this quite mysterious substance that doesn't emit light or interact with light, but because it has a gravitational influence, and its gravitational influences causes stars to move fast when there's a lot of dark matter, or slowly when there's not very much dark matter. We can therefore sense the amount of dark matter by measuring the velocities of stars, and that's exactly what we're trying to do tonight with that's one of the many things we're trying to do tonight with our spectroscopy. Now, here are this field that you see in gray and white and black is the patch of sky that we're looking at. You can't actually see the particular stars that we're getting spectra of because their light is not being reflected. The light is going through cuts in this metal plate into the spectrograph. And I think the first spectrum, when it comes out, will appear on this screen here that I'm circling. So Alessandro and Ivana have started a sequence of exposures, and it's about a third of the way, 35% of the way into a 30-minute exposure. 1800 seconds is, actually my screen is frozen. I'm not seeing an update. So because this number is meant to be So I'm going to stop my screen share and reshare in case there's a problem with my screen share. No, it's not even a problem with my screen share. It's a problem with my VNC. So I'm actually going to restart some software here. Just bear with me one moment, please. All right, I'm going to restart this software. My poor computer is working very, very hard, and it was frozen when it came to displaying all of the telescope control stuff. So I'm restarting all that.
So I'm just gonna stop my video here, but I'm around, so I'll be lurking in the background if anybody has questions about operating telescopes or whatnot.
Thank you, Rita. Thank you very much for taking the time to spending some time on this call. Okay. My computer still
Sir, I
being
have
slow.
question.
Yes, please go ahead. Go ahead. Please ask your question.
Sir, is the equator hottest place in Earth?
Is the equator the hottest place on Earth? Is that what you were asking?
Yes, sir.
It's not. In general, I would say that would be an oversimplification of the situation because, first of all, do you mean today or average temperature around the year?
Sir, average temperature.
In terms of average temperature, generally places near the equator tend to have a high average temperature, high annual average temperature, but the location on the Earth, that means its proximity to whether something is close to the equator or not, is not the only factor that determines its annual average temperature. Obviously, it depends on whether it's located close to the ocean or deep in the interior. These things matter because when a city or town is located close to the ocean, the influence of the ocean is to generally to make the daytime temperature cooler than a place that's far away from the ocean, make summer temperatures cooler than for a place close to summer temperatures are lower for a place close to the ocean than a place far away, and opposite for winter. Winters tend to be less severe, less cold and severe when a place is located close to the water. So proximity to water, the nature of the winds around, these are also factors. It's not purely latitude of the place on Earth that determines its average annual temperature. Yeah, go ahead, Walker. Do you have a question, please?
What if two stars collide into each other?
What would happen if two stars were to collide into each other? These things do happen. They're not very common. It's not like the sun is, we don't expect the sun is going to collide with another star. We don't think that's happened to the sun in the past, but stellar collisions do happen. And typically they can happen in a couple of different ways. They tend to happen in very dense regions. And one of the ways in which they can happen in a non-dense region is stars can sometimes get into binary systems. Not that infrequently, in fact, stars can be in binary systems, that is one star orbiting another star. And then that can lead to, if not a collision, it can lead to interaction between the two stars. In fact, Alessandro and I were just talking about the possibility of stars being binary systems and how one star would interact with the other. We know we have recently seen gravitational waves from the collision and merging of neutron stars, which are a kind of dead star. That created a lot of excitement and news. Before that, there was the first detection of merging black holes or gravitational waves from merging black holes. So stellar collisions, while they're rare, they're not unheard of. They have happened. We've been able to detect them. For a long time, many years ago, when was it? In the early 30 years ago, I was studying a class of stars called blue stragglers. And one of the ways they can form is through collisions of stars. It looks like Future Hope, you're getting ready to ask a question. Go ahead, please.
You just told about dark matter a few minutes ago, like it doesn't interact with any light. So how do you prove its existence? Like, how does it exist?
Yeah, so it's a very good question. I mean, I think right now, dark matter is postulated to exist as a means of explaining how things move. Galaxies spin. The Andromeda galaxy, if it did not have dark matter, if it were only made up of stars, would spin at about 80 kilometers per second. That would be its spin speed. Its observed speed of spinning is more like 250 kilometers per second. Now, people have asked the question, why is it spinning? That's how the discovery was made, right? Vera Rubin was measuring how fast galaxies spin, and she found that Andromeda, if you just count all its stars and you do the mathematics and physics properly of how their gravity should collectively act on the galaxy, she would have predicted a rotation speed of about 80 kilometers per second, about a little less than 100. And when she went and measured the actual speed of rotation of Andromeda, she measured something closer to 250. Now, initially, she said, she called it missing matter. She said there's some kind of matter whose gravity must be causing this thing to spin rapidly, but we can't see the matter, so she called it missing matter. But then later it came to be known as dark matter because the matter is not missing. What's missing is light, that it might be, other forms of matter glow in light or they reflect light. This matter doesn't interact with light or emit light. So you're asking a very good question. I don't think, I think it's the most popular explanation among astronomers that this galaxies rotate faster than they would if they only had stars because of this presence of invisible matter, but that has mass and produces gravity. But there are other attempts to explain this away. There's a particular thing called MOND, modified Newtonian dynamics. And we were just talking about that the other day. I was just talking about that the other day with a student. I think we should ask Alessandro and Ivana if they agree with this, but I think dark matter is seen by astronomers as the most conservative and down-to-earth explanation for how galaxies move. Do you guys agree? The question is, how do we know dark matter even exists?
I would tend to agree to this, yes. And I think, I think you touched on this. There are a couple of ways of explaining what we're seeing. And I think both of them deserve recognition because I think both of them address one fundamental limitations is that we have two different physical theories. One is about particles and one is about gravity, and they do not agree with each other. And I think dark matter sits exactly at the interface between these two. And so the dark matter hypothesis would explain our observations invoking particles, and the other part would explain observations invoking different behavior of gravity. I am personally more convinced that dark matter has a little bit of a stronger case. Yeah, so I do agree.
Ivana?
Yeah, I agree. I don't think I have anything else to add.
And I think one of the things you're seeing in science, this is generally true in life, but it's very true in science, is unlike the way we are taught science in a textbook that this is correct and this is incorrect, there are many things out there where the knowledge is incomplete. And it's not a black and white, clear cut, this is correct, this is incorrect. There's large areas of uncertainty. And how galaxies move and what the explanation for them is, at least today, sits somewhat in this area of uncertainty. And maybe 20 years from now, or maybe 5 years from now, or 50 years from now, maybe it'll move more into an area of certainty than it is now. And that's how science progresses. That's how knowledge progresses, right? I mean, I'll give you an example. If you think about the COVID-19 virus, today, doctors around the world are struggling to understand how this virus might mutate and how we, create viruses how we create vaccines to protect against this virus. And years ago, there were other viruses that were deadly to humans, smallpox being one of them. Today, we have a complete cure for such diseases. So that virus, we now have a perfect counter to. And maybe there'll come a day when the coronavirus and the flu virus will be completely controlled by medication. And this is how science progresses. But that's a great, yeah, go ahead, please. That was a great question about dark matter, by the way.
So I have a question.
Go ahead, please.
Why do all planets look different?
Why do different planets look different? Vicky, I'll see you later. Thank you. Thank you so much. Why do planets look different? That's a great question. I don't, I'll give you a rudimentary explanation. This is not my area of research, but I'll give you a rough explanation. Planets look different because they're made up of different things. So some planets, like the Earth, are made up of, they're called terrestrial planets. They're made up of rock. Do you know the other terrestrial planets in the solar system, in addition to the Earth? They're called terrestrial. That means they're made of rock. Yeah. What are the other terrestrial planets? Go ahead. Which is the closest planet to the sun?
Mercury.
Yeah. So Mercury is a terrestrial planet. What is the next planet out?
Yes.
Venus, right? So Venus is also a terrestrial planet. Then Earth. What about Mars? Is Mars a terrestrial planet? It is. It's also made of rock. The next 4 planets beyond Mars, do you remember their names? They're big planets.
So entirely made up of gas.
They are made up of gas. They may have a rocky core at their very center. There's some
But
models.
most of it made up of gas.
Say that again?
Most of the Jupiter is made up of gas.
Most of Jupiter is made up of gas, yes.
There's a constant storm going on Jupiter's surface.
That's right. That's right. The great red spot, giant red spot. But it's not just Jupiter. Jupiter, Saturn, Uranus, Neptune. These are called gas giants. They're much bigger than the other planets. And they're mostly made of gas, as you said. And there's some, I'd heard, again, I'm not an expert in this, but I'd heard that they may have rocky cores. They may have rock, solid or molten interior. But the moons of the planets, like we were talking about the moons the other day, Ganymede, Europa, Callisto, Titan, moons of some of these gas giants, they are terrestrial. Our own moon, the moon that goes around the Earth, is also terrestrial, of course. So the thing that gives planets different appearance, of course, depends on what they're made of, whether they're made of gas or rock. And then also depends on the chemical composition of that material. It depends in Venus. Venus has very thick clouds on its surface, very thick. Imagine, the Earth's surface sometimes has clouds, but sometimes you can see a clear blue sky. Venus is constantly cloudy, very thick clouds. So how sunlight reflects off that determines the appearance of Venus. So the appearance of a planet depends very much on its composition, its chemical composition, but also its physical state, whether it's gas, whether the surface is, most of the Earth's surface is liquid. That's what, we call our planet the blue marble. It looks blue because of the reflection of the water. Now, one of the really cool physics things about planets is the further away a planet is from the sun, the fainter. No, I shouldn't say that. If you had two planets going around in the solar system, one that is, let's say, going around at the same radius as as Pluto's orbit, say, and another one that's 10 times further out, but otherwise the same. Both planets are made of the same material, they have the same chemical composition, they're both terrestrial planets, say. So one is orbiting, they have the same radius, so one is orbiting at Pluto's orbital radius, and the other one is orbiting 10 times further out. Which planet would look fainter to us, and why? Which planet would be fainter, the further away one, or the one that's
Further away.
the one that's further away? Do you know how much fainter it would be? Again, it would be 10 times further away. How much fainter would it be?
Fainter. Like the larger the distance, the more fainter it is.
The larger the distance, the fainter it is. But if it's 10 times further away, is it 10 times fainter? Or is it, how many times fainter would it be? From our perspective, how faint would it be?
10 times fainter.
How many times?
10 times.
It wouldn't be 10 times fainter. Okay, so let me explain. If you had two light bulbs, okay, one is located, say, 20 meters away, another one located 200 meters away, but the same light bulb, 100-watt light bulb. The one that's located 10 times further away would look 100 times fainter. This is something called the inverse square law of distance that for light, okay? Now, in planets, it's even worse because the one that's further away is not reflecting as much light as the one nearby because it's getting less sunlight. So it would actually be 10,000 times fainter. Not 10 times fainter, not 100 times fainter, but it goes like 1 over distance to the 4th power. It would be inversely proportional to distance to the 4th power. That's how planetary brightnesses work for, let's say, for outer planets in the solar system. And I'm happy to, happy to go over that in more detail if you want sort of a more. Yeah. Go ahead. Yes, Alessandro. Are you trying to reach us, Alessandro? Are we bothering you? No. He was waving to something else. Go ahead. Yeah, please ask your question.
Maunakea there in the universe?
How many what? Sorry.
Maunakea.
I didn't understand your question. Try again, please.
How many Maunakea are there in the galaxy? Universe.
I'm missing. So I'm going to type the question. You're asking how many? Then I'm missing the word you're saying.
Group of galaxy.
Sorry. Just how many galaxies are in the universe? No.
She's asking how many groups of galaxies are there in the universe.
Oh, how many groups of galaxies are in the universe? That's a very good question. I don't know. Groups of galaxies, not individual galaxies. That's actually a very difficult question to answer because sometimes groups live within bigger collections. So do I count the smaller groups or do I count the bigger collection that the groups are part of? So it's a little difficult to answer the question this way. One thing I can give you a rough idea about is astronomers measure distances in units of megaparsecs. A megaparsec is about 3 million light years. So the typical distance between galaxies is typical distance. Of course, sometimes galaxies are closer, sometimes further, but the average distance between galaxies is about 1 megaparsec, which is about 3 million light years. And of course, we can see out to not 1 million, but 14 billion light years. So if you imagine a sphere whose radius is 14 billion light years, and you have galaxies whose typical separation in 1 million light years, you can easily calculate how many galaxies would be within that volume. Okay. You know how to calculate the area of the volume of a sphere, right? 4/3 pi r cubed. If you calculate that volume, and then you know the density of galaxies is 1 per cubic megaparsec, then you can calculate the number of galaxies in the part of the universe we can observe today. Does that make sense?
Yes, sir. Thank you.
Sure.
Excuse me, sir.
Yeah, please go ahead.
I heard that in some other planet, it's a diamond ring. Is it possible?
I've heard this too, not diamond rings, but I've heard that there are bodies in which there's such high pressure, such high compression, that carbon would exist in sort of crystalline form like that. So you can have very dense and compressed astronomical bodies. Some of the densest things we know are things called neutron stars and black holes. But I've heard about situations where you can have highly compressed carbon. So you wouldn't have a beautifully shaped diamond ring there, but you would have, just like in a diamond mine on Earth, where you can mine for diamonds. It's the same phenomenon. Like pressure of the pressure of the Earth's surface has caused carbon to be present in that crystalline form that we call diamond. Does that help answer your question?
Yes, sir. Thank you.
Yeah, I don't think there are planets out there that are purely made of diamonds. That I don't believe.
Excuse me, sir.
Yeah, go ahead.
What happened after going inside the black hole?
What about going inside a black hole? What was the question?
What happened after going inside the black hole?
Okay, so what happens even before something falls into a black hole? As something approaches a black hole, let's say, let's not think about humans, let's think about something inanimate, right? So you know that Australia and India played a cricket match earlier today, right? You know that. There was a T20 match. Do you know who won? India won. Okay. So if you take a cricket ball, and let's say Virat Kohli hits a very big six, and ball goes outside the stadium, and it travels far away, and it gets trapped by a black hole. It starts falling into a black hole. What happens is, as something starts falling into a black hole, what would happen is the part that's closer to the black hole, the ball has a finite size, right? The cricket ball, I'm using my fist to show, simulation of a cricket ball. It has a finite size. It's not point-like, it has a finite size. So as something with a finite size approaches a black hole, the near side feels a stronger gravitational pull than the far side. So let's say my hand is a cricket ball, and let's say the bottom of the screen is the direction of the black hole. The lower part of my hand, the lower part of the ball, will experience a stronger downward pull than the upper part, and that will stretch out the ball. Okay, to stretch it out, it will no longer be a sphere, but it will become sort of cigar shaped. And the moment that starts to happen, now there's an even bigger difference between the near and far sides. So this effect runs away, turns the cricket ball into what looks like a piece of spaghetti, becomes like a string. So it doesn't all fall in at the same time, but the near part falls in first, and then the far part falls in later. So if a person were to fall into a black hole, this process would kill them, because the amount, if you can imagine, if you take a person and you stretch them out with the gravitational forces that a black hole exerts, that would spaghettify the body and kill the person long before they fell in. So this effect of differential gravity, one side feeling a stronger gravity than the other, is called tidal forces. I'll put the name in the chat. Tidal forces. And you're all familiar with tides, the effect of tides on the river Hooghly, which is near Kolkata, or the effect of tides near the Pacific Ocean, the part of the Pacific Ocean that's near Molokai. These are, I work in a town called Santa Cruz, and there the effect of tides is seen very easily. And what happens there is the near side of the Earth is being pulled harder than the far side of the Earth by the moon and the sun. And that produces the bulging of the oceans that causes high and low tides. So I tried to answer your question about black holes, but I wanted to put this in the context of differential gravity, tidal forces. Yeah, go ahead, please.
I have a question.
Yes, please.
So what's the amount of pressure in space and what's the amount of pressure inside a black hole?
The amount of pressure inside a black hole. So first of all, the amount of pressure in space, that was your first question?
Yes, sir.
Yeah, so space is mostly a vacuum. So there isn't the same kind of pressure that we experience here on Earth. The pressure we experience on Earth is the weight of the Earth's atmosphere, the air on us. And even for astronauts who go to the moon, there's much less atmospheric pressure. And certainly if you went into outer space, there'd be close to zero pressure. Now, due to the kind of air pressure that we feel here on Earth. Having said that, this kind of tidal forces that act on bodies, that creates very extreme effects. And one of the strange things about black holes is we can't really describe their interiors. We can talk about what happens when things approach a black hole from the outside, and they approach something called the event horizon. The event horizon is the point of no return beyond which even light can't escape from the black hole. So we can only really describe it from the outside and what happens near a black hole on the outside. We can't really describe with any confidence what happens inside. Now, I think last time we were talking about this thing called John Wheeler's theorem, a black hole has no hair, the loss of identity of matter. So there's a lot been written about that. And those are the only things I have come across that talk about the interiors of black holes. That's a long answer to your question, or a long attempt to address your question. It's not really an answer about pressure inside a black hole.
Okay, sir, no problem. Thank you.
Thank you. These are great questions. Yeah, go ahead. Yeah, please.
My question is that in Earth, the plants need sunlight, water, and air to photosynthesis. But if this condition applies in Earth, but is there any possibility that other conditions apply in other planets?
Yeah, so this is something that my wife is very interested in. Recently, they did some experiments where they took something called regolith. I'm going to put this name in the chat. By the way, when I put something in the chat, can the Future Hope students see what I'm typing into the chat? I assume the others can, but are you able to see it? I know because you're sharing one Zoom connection. Are you able to see what I just typed into the chat? Yes? This is a question for Future Hope. Are you able to see what I typed into the chat of the Zoom connection? No?
Sir, can you repeat your question?
My question is, I just typed something into the chat portion of the Zoom connection. And are you able to see what I typed in there? Is there, which computer is being used to run Zoom?
Yes, we are able to see that.
You are able to see that or not?
We can see.
Okay, can you see the last word I typed in there? If you can read that out for the students? Regolith. Regolith is a fancy word for lunar soil from the moon. So you all remember, or you all have heard of, not remember, you all have heard of the Apollo mission, where NASA sent humans to the moon. That was over 50 years ago. sorry. Alessandro, am I bothering you? Or should we stop for a moment, or are you okay with your mask change? We must be okay. I can't hear Alessandro. Okay, so what you were asking about plants requiring oxygen and water and soil for growth and requiring carbon dioxide, etc., for photosynthesis. Recently, some scientists from Florida did some experiments where they took lunar soil, not soil from the Earth, but lunar soil, and that's called regolith. Basically, it's very crumbly rock that was collected by the Apollo astronauts over 50 years ago. They took this regolith, they added fertilizer, water, and they found that plants could grow in regolith. It didn't grow as well as when they were given earth soil. Of course, the nutrients they were getting was from the fertilizer, not from the soil itself, but from the fertilizer. But to their surprise, plants were able to grow. They didn't grow as healthy. They weren't as healthy as the plants that grew with earth-based soil. But so people are doing experiments to learn more about the survivability of plants and humans and other living things in the space environment. Again, that's a very long answer to something you asked, but these are very good questions you're all asking.
Thank you, sir.
And before you ask your question, Rob, I didn't mean to ignore you. If you wanted to introduce yourself, please feel free to do so. Go ahead.
Hello, sir. I'm Sandeep.
Please repeat your start again, please.
Mohammed Sabir of class 8.
Hi, Mohammed.
My question is, sir, that we already reached the space, but we are unable to explore our own oceans. Why is that, sir? Are we lacking some technology or something?
We are lacking a lot of the technology, and in both the exploration of space and the exploration of the deep oceans, there is much, much more to explore than we have explored so far. So in both cases, whether you're talking about the exploration of space or the exploration of the oceans, our knowledge is very, very incomplete at this point in time. So it's not like we're doing better in one than the other. We know very little about both. Okay. The deep oceans are very difficult to probe, of course, because the very high pressure, lack of light. But of course, there are living things that can survive. There's no sunlight getting into the very deep parts of the ocean, and very high pressures, but creatures manage to survive. There are deep sea creatures, of course. Now, it's not that there's been no exploration. There is a lot of exploration. There's ongoing exploration. We're learning more and more about our oceanography, and especially studies of the deep ocean are a very active field of research. Just like space research is a very active area of research. So it's not like we're doing one and not the other. We're exploring both. Okay. Shabir, does that answer your question?
Thank you, sir.
Thank you. That's a very good question. Thank you. And you said your name is Mohammed Shabir, is it? Very nice to meet you, sir. Go ahead, other questions. And I'm keeping an eye on the time. I know that it's approaching lunchtime for Future Hope, right? Doesn't your lunch start in 2 minutes?
Yes, sir.
Okay. What are they going to serve for lunch today in school? Do you know?
Yes, sir, we don't know. We'll go and see the menu.
Is it different things on different days of the week, or different weeks? How is it?
Sir. Every Friday, the egg is cooked. Egg
Every Friday, what did they do again?
A curry, dal, and rice
I see.
and salad. And all
But next week, rotation of vegetables, you can say.
Yeah, what vegetables are in season right now in Kolkata? What fruits and vegetables are in season right now?
palang saag,
Okay.
cabbage, rice, bhindi.
Okay, so bhindi is okra. I'm going to translate in English. Okay, so palak is spinach. What was the other thing you said? Palak, bhindi. What else did you say? Cabbage. Cabbage, yeah. Cauliflower as well. Gobi.
Potol.
I don't know what the English word for potol is. That's a. Now, all this talk must be making you hungry. Okay. Other questions? Other questions? Go ahead. Is Sujata ma'am in the room today? Is she in the school today? I want to. Are any of your teachers in the room today?
Yes.
They are. Okay. I will
Yes,
also
sir. We
say.
have our social science teacher with us.
I can't. Because of the angle of the camera, I can't see them. Oh, there you are. Okay, thank you. Hello, ma'am.
Thank you, sir. Thank you, sir.
No, I'm so impressed by your students and your school, of course. Your whole organization has been. I'm of course. I've never visited, but it all started with a brief Zoom conversation with Sujata ma'am. And that was, it feels like I've known her for a lifetime now, even though our first conversation must have been 2 weeks ago. But I'm really, thank you for.
Explained. Thank you, sir. Thank you so much for nice.
Yeah, and I hope, of course, we'll be doing many of these sessions going forward. This was a long set of sessions we're doing in September.
Yes.
Yes, generally, they'll be more infrequent. There won't be such a long set in a row, many nights in a row like this. But there, I'll always send out an invitation. And that's a very good. Trichosanthis dioica is the English name of pottle. Wow, I had no idea. But no, but also I don't. Obviously, I don't want to impact the students' classes. That there was the normal regular subjects that you'd be taking for school. I don't want to have a negative impact on that by taking time away from that. So we should do whatever makes most sense for the school. We'll be offering these opportunities all the time, several opportunities every month going forward. But I'm very grateful to you, the teachers of the school, and to Sujata for making this connection and making this opportunity happen. I think all sides are fortunate for this connection to have happened. So thank you. Yes, please.
Sir, can we leave? We have our lunch time now.
All right. No, please go ahead. Of course. Go ahead, enjoy lunch, and I will. We'll be back here next 2 nights. We'll be doing the same thing. So please join if you can.
Thank you, sir.
Thank you for the lovely, sir. Lovely, sir.
Have a nice day.
Good night, sir. Shubhratri.
Shubhratri. So remember your one thing. Don't forget that there was that session a few nights ago that I forgot to record. And please put together a Google Doc in which you write down some of the questions and topics we discussed, just as a way of documenting that session. Okay.
Okay, sir.
Take care.
Thank you.
Bye. Bye.
So I think I'll sign off as well.
All right, Rita, take care. I'll head over to the room in a moment also.
No worries. Thanks.
Bye. Thank you. Hey, Rob.
Hi. Didn't mean to ignore you there a little while ago. I was
No,
just
no, no. I know there was a lot of
couldn't
talking
get to
going
my
on.
couldn't get to my unmute fast enough.
No problem. Where are you connecting from, Rob?
From Los Angeles.
You are, okay.
Just got back from vacation in Mammoth, so that's why I missed some of the earlier
Oh, no problem.
things this
Where
month.
were you on vacation again?
In Mammoth,
In
Lakes,
Mammoth.
California.
I see, I see, I see.
Yeah.
Did you find out about us through Griffith or some other source?
Well, from Griffith originally, but I think I also a friend of mine, his daughter is at Santa Cruz, and I think they might have mentioned it as well.
Oh, I see. Oh, fantastic. Very nice. Very nice.
But yeah, I am part of the Griffith support people. Yeah.
Oh, wonderful, wonderful. So you must know David Reitzel and others.
Yeah, I've seen him on some of the.
David used to be my PhD student many years ago.
Great, cool.
Um,
Yeah,
was-
no, I've loved to go to the Griffith Observatory ever since I've been a kid. That was the favorite place to go to birthday parties.
It's such a special place, such a special view of LA. Really.
Yeah, it's yeah, I've done a lot of stuff. I do a lot of astrophotography up at
You
Mount
do?
Pinus
Okay,
and stuff like
okay.
that. Yeah.
I see, I see. I'm trying to share my, yeah, there we go. This is, I suppose we are doing astrospectroscopy today.
Right.
But we do a lot of, Keck isn't used for that much imaging. It's mostly for spectroscopy.
Exactly.
And
But yeah, you have the same problems that you have and the same procedures for photography as you do for spectroscopy.
yeah, and we're all using digital devices now, silicon devices. And yeah, one of the barriers is the air glow of the night sky, of course. I mean, the air glow, human-made contributions to that glow.
Right.
Where do you go to Mammoth for photography usually?
No, I took my telescope there once on vacation, but usually I go to Mount Pinus and do photography there.
I see, I see.
It's a little bit better than LA. There's also a place down in the mountains south of Thousand Oaks that
I see.
overlooks the ocean.
I see.
And you get a nice, clear, steady sky over the ocean when you look out that direction. So for a southern exposure, that's a great place.
I see.
Planets
I
and
see.
things like that. Yeah.
I see. Wonderful. What planets are visible in the evening sky now? Jupiter, Saturn, anything
In
else?
the later evening sky, Jupiter and Saturn, and as you go later, Mars. But in the early evening sky, there's not really too much. I mean, Jupiter's there.
I see.
But
So Venus is now an early morning star, right? Not an evening
yeah,
star.
it's disappearing. It's going behind the sun.
Got you. Got you.
And so it'll be back in the early evening sky. And it takes a long time to get
in a
back
couple of
there.
months, right?
Yeah, a few months maybe. Yeah.
Yeah.
But yeah, I've been watching it disappear, sink slowly as I take my walk in the morning.
No, I remember a time when Jupiter and Saturn a few months ago when they were very close together on the sky.
Right. Yeah, they are. They're still. You can see them at the same time.
You can see them
It's
at the same time,
a
right?
little bit later at night right now. Yeah.
Yeah.
No, but I haven't had a chance to go up and do any observing in a dark site for a while.
Got it.
Though when I went outside at Mammoth at night, you can see things, but I didn't have a telescope to use. So
I see. How long have you been doing astrophotography?
well, astrophotography. I actually started my astrophotography back in 2004.
I see.
But I've been observing since 1972
I see.
with telescopes.
I see.
But I pretty much started astrophotography when they came out with digital cameras.
I see.
As I did do a little bit when I went to UCLA as an undergrad. I did do a little bit of film astrophotography, but
Wow.
very little. Yeah, I used to teach math at UCLA back in 86 to 88.
Okay. Okay.
That kind of gives you an idea of my age too.
86 to 88. I had finished my PhD in 89, so I was in grad school, 86 to 88.
Yeah, I just gotten back from Princeton at back then. Taught a couple of years there, and then I got hired away by Apple. So
I see. So I was a grad student at Princeton from 85 to 89.
85 to 80.
Yeah. I wonder
Okay,
if we overlapped there.
85 is about the time I left. That's right. So you got there just after I left, right?
And you were a student there, or were you teaching there?
No, I was a student,
You were
grad
a
student,
grad student. Which department?
math.
In math. Okay, so fine hall, right?
Right, yeah. Yeah, I had
So-
Stein was my advisor at the time.
Who was, sorry?
Huh?
Who did you say your advisor was?
Elias Stein.
Okay, I don't think I know the name, but you're right next to your building was Jadwin Hall, and then
Right,
Peyton
yeah,
Hall,
physics across the plaza there, right?
the plaza, and then Peyton Hall, the very small building, was where I was a grad student, the astronomy building with the little dome, the telescope on
Right,
top.
right, okay.
On Ivy Lane, which is, you were, Fine Hall was just very close to Ivy and Washington Road.
Right.
And, yeah, and Peyton Hall was right on Ivy,
Okay, yeah,
close to the stadium. The stadium was the old stadium. Now they've
Right,
completely
great.
revamped it. Yeah.
right, yeah, I remember that.
Was,
I didn't see much going on there, but
oh, wonderful. I guess John Nash must have been in and out of your department when you were a student there.
he was, but he mainly was wandering the halls at the time.
I know what you mean. He would actually wander that path between Peyton and Fine. I would see him outside. I didn't know who
Right.
he was at the time when I first saw him.
Sure,
But-
sure.
Yeah.
Yeah, you could talk to him, but it wasn't terribly coherent at the time. It was before he got better.
I see. Yeah, I knew someone who was a librarian at Fine Hall, and she would occasionally find him come in the morning and find him asleep in the library, sometimes in the
Uh-huh.
in the
Yeah.
halls, in the sort of passageways between the book stacks.
Right,
Yeah,
so-
he was pretty unwell then.
right. I was so glad to hear that he got better later,
Yeah. But he died tragically, completely
Yeah.
preventable, not wearing a seatbelt.
Right,
But he and his wife, I guess, passed away from that in that accident.
yeah, it's too bad. Yeah, no,